So therefore, we have the u, the x is equal to 3 times 3 is 9. So we have 9x, 3 minus 1 is 2. That is our du dx. Hello, welcome to Basic 2 Tech for students, teachers, and math education. Today we're doing product of functions, which is a part of calculus. Before we continue, let's quickly do a recap of some basic differentiation. We know that when we have, for example, y is equal to x to the power n, the formula for differentiation is with respect to s is dy over the x is equal to the power multiply the function. So we have n times x, then we subtract 1 from n, which is the power. So we have n minus 1. Again, when we are differentiating a constant with respect to x, it gives us 0. When we differentiate sine x with respect to x, it gives us cos x. Again, when we differentiate cos x with respect to x, it gives us a negative sine x. And when we differentiate exponential x with respect to x, this gives us exponential x. These are very basic and also useful differentiation that we have to know as we go into the world of calculus. Let's return back to our today's topic, which is the product of functions. For example, we are given y is equal to u times v, where u and v are functions of s. For us to solve this with respect to s, the formula is dy dx. So we are differentiating this function with respect to s. The first thing we do is to put down the first function, which is u. So we'll put down u, then we multiply this with the differentiation of v. So it's u times differentiating v with respect to x plus we put down the second function, which is v, then we multiply it with differentiating u. So we differentiate u with respect to x. This is how we differentiate products of functions. Again, we put down the first function and we differentiate the second function with respect to x. Plus, we put down the second function and we differentiate the first function with respect to s. Let's look at some questions. Here is a good question. Differentiate y equal to 3s cubed times exponential x. Again, as you can see, this is a product of two functions. Here is our first function, we call it u, and here is our second function, we call it v. Remember the formula, which is dy dx is equal to u dv dx plus v du dx. So let's start with the first function. The first function is u, and we have u, and u is equal to 3x cubed. And if we differentiate u, we have du dx will give us, remember, the power will multiply the function. So we have 3 times 3 x, then we subtract 1 from the power, so which is 3 minus 1. So therefore, we have du dx is equal to 3 times 3 is 9. So we have 9x, 3 minus 1 is 2. That is our du dx. Our next function is v. So we have v is equal to exponential x. And remember from our last slide, when we differentiate v with respect to x, we get exponential x. So the v dx will give us exponential x. So now we've known all our variables. So our u is 3x cubed, the v dx is e to the power x, our v is exponential x, and our du dx is 9x squared. So right now we substitute into the equation. So my u is 3x cubed times my dv dx is exponential x plus my v is exponential x multiplied by du dx is 9x squared. So 3x cubed times exponential x gives us 3x cubed exponential x plus exponential x times 9x squared will give us 9x squared exponential x. So this is our answer. But we can simplify this equation by factorizing. And we have something in common. First thing we do is to open the bracket and we look at the common number between both this and this. So we have 3, we have 9. So 3 can divide 3, 3 can divide 9. So I'll bring out 3. Here I have x squared, I have x cubed, so I can bring out x squared. I have exponential x, I have exponential x, so I'll bring out exponential x. If you want to learn how to factorize, please leave a comment in the comment section and I will make a video on factorizing. So when we divide this common factor by this, we get x plus 3 divide 3 divide 9 is 3, x squared divide x squared is 1, and exponential x divide exponential x is 1. So our answer is 3x squared es open bracket x plus 3. So this is our final answer. Let's look at the next question. Here we are given y equal to cos s times sin x. Again, we have two functions. Here's our first function, we call it u. Here's our second function, we call it v. Remember, to differentiate the product of functions, we use dy dx equal to u dv dx plus v du dx. So let's try our best to find what are these variables. So as we know, our u is cos s. And when we differentiate du with respect to x, it gives us a negative sine x. All right. Next is v. V is equal to sine x. And when we differentiate v with respect to x, we get cos s. All right, so we know all our unknown. So back to our question. So therefore, dy dx will be equal to my u is cos s. So I have cos s times dv dx is cos s. I have cos s plus v is sine x and du dx is negative sine x. So therefore, our dy dx is equal to cos x times cos s will give us cos squared x. Now we have a plus and a minus. So a plus times minus is minus. Sine x times sine x will give us sine squared x. So this is our final answer. So when we differentiate cos s sine s, we get cos squared x minus sine squared x. It's used to differentiate division of two functions. For example, we have y equal to u over v, where u and v are functions of x. If we are to differentiate this, what we do is, firstly, because u and v are functions of s, so it is dy over the x equal to, we put down the bottom function, which is v, then we differentiate the numerator, which is becomes du dx, then minus, this time we put down the numerator, which is u, then we differentiate the denominator, becomes the v over the s, then we divide everything by the denominator, which is v squared. So this is how we differentiate division of two functions. Let's look at some examples. Here we're asked to differentiate y equal to 3x squared over cos s. What we'll do first is to call the numerator, we call this u, and we call this v. So therefore, my u is 3x squared. If I differentiate u with respect to x, becomes du over the x. That will give us, remember, to differentiate, the power multiplies the whole function. So 2 times 3 is 6, then x, then we'll subtract 1 from the power. So 2 minus 1 is x. So when you differentiate 3x squared, we get 6x. Next, we have v. Our v is equal to cos s. Again, we have to differentiate v with respect to x. So when you differentiate the v, the x, that will give us negative sine x. If you want to know how we do this differentiation, you have to watch our previous video that you see on the top right corner. So therefore, to differentiate this quotient, what we'll do is dy dx is equal to, remember, is the v du dx minus u dv dx over v squared. So now we've gotten our v, our u, we've known our du and our dv. So let's put them to the formula. So our v is cos x times du dx is 6x minus our u is 3x squared dv is negative sine x over our v squared. Our v is cos s, so it's cos x all squared. So what we have next is cos s times 6x will give us 6x cos x. Now negative times negative will give us a plus. 3s squared times sine s will give us 3s squared sine x over cos s squared will give us cos squared x. So therefore, this can go for our final answer. But if you want to factorize the numerator, you can do that. So that will give us, again, first I will open a bracket. Now, the common factors for 6s cos s and 3s squared sine s. Now, 6 and 3 is the common factor, so I'll bring out 3 first. I have x squared, so I'll bring out 1x. So 3s divided by 6x cos s will give us 2 cos s. That'll give us 2 cos s plus 3s divided by 3s squared sine s will give us s sine s. Let me take this off. That's s sine x over cos squared s. So this is our final answer. So when we differentiate 3s squared over cos s, what we get is 3s open brackets 2 cos s plus s sine s over cos s squared. Let's look at a different question. Here we're asked to differentiate cos s sine s. Remember the formula we use to differentiate is dy over dx equal to v du dx minus u dv dx over v squared. And again, the numerator is our u and denominator is our v. So u is equal to cos s. Remember, when you differentiate du with respect to x, that will give us negative sine x. Our v is equal to sine x. Differentiate v with respect to x, that will give us cos s. So what we'll do next is to put in these into the equation. So what we have is our v is sine x times our du dx is negative sine x minus our u is cos s and dv dx is cos s over v is sine s all squared. So therefore what we have, sine x times negative sine x will give us negative sine squared x. Negative is negative. Cos s times cos s will give us cos squared x over sine s squared will give us sine squared x. So now here's our equation, but we can still simplify further. So what we do now is to use this negative sign to multiply everything right there. So we can rewrite this equation as open bracket, negative comes out right here. So negative times negative sine x squared is a plus, so that gives us sine squared x. So negative times this negative is a plus, that gives us cos squared x over sine squared x. Now, in your trigonometry, we are told that sine squared x plus cos squared x is equal to 1. So therefore, sine squared s plus cos squared s is 1. So therefore, this is negative 1 over sine squared x. Again, in your trigonometry, 1 over sine squared s will give us cosec squared x. So therefore, negative 1 over sine s squared becomes negative cosec squared x. So this is our final answer, negative cosec squared x. If you want to learn how to do trigonometry, leave a comment below and we shall make a video on that. Function of a function is of this form, where you have y equal to sine x, for example, where y is a function of the angle x. All right. Now, this is so because y depends on the value of x. So for us to differentiate a function of a function, we call the independent variable is u. Remember, y is the dependent variable and x is the independent variable. So the first thing we do is to assign u to the independent variable, and therefore we now have y equal to what? Sine u. All right. So to do this now, we differentiate the first function that will give us the y, the x. So what we'll do next is to differentiate y sine u. That will give us the y du times. Next, we differentiate u. Remember, u is equal to x, so that becomes du dx. So here is our formula for differentiating function of a function. Remember, when we multiply this, we get back dy dx. So let's look at some examples. Here we're asked to differentiate y equal to sine 4x plus 3. Remember, this is the independent variable because you have the x there. So first thing first, we call this independent variable, we call it u. So we have u becomes what? 4x plus 3. Now, our y is now sine u. All right. So let's differentiate u with respect to x. That gives us du dx. Will give us what? Now, here is like a polynomial. We differentiate each term separately. We'll differentiate 4x. We have 4 plus 3 is a constant. When we differentiate a constant, we get 0. So differentiating 4x plus 3 is 4. Now, we have y equal to sine u. When differentiate dy with respect to u, remember, when differentiate sine, we get a cos, so that gives us cos u. So therefore, to differentiate this function of a function is the y dx equal to what? The y du times du dx. So our dy du is cos u times our du dx is 4. So therefore, The y, the u, the x equal to what? Cos u times 4 is 4 cos u. And remember, u is equal to 4x plus 3. So therefore, we have 4 cos u is 4x plus 3. This is our final answer. Let's look at our next example. Here we asked to differentiate y equal to 2x minus 5 all to power 4. What we do here is this. Again, y is the dependent variable and x here is our independent variable. So we call this equation right here u. So what we have is, therefore u is equal to what? 2x minus 5, and y is equal to u to the power what? 4. Now we differentiate u with respect to x. So we have du dx. Again, 2x will give us 2 because x has power 1. So 1 times 2 is 2. Then 1 minus 1 is 0. So that gives us 2 minus 5. 5 is a constant, so that gives us 0. So when we differentiate 2x minus 5, we get 2. Now, differentiate y with respect to u. That will give us 4 the power times the function. So we have 4u. Then we'll minus 1 from the power, which is 4 minus 1 will give us what? 3. So when we differentiate y with respect to u, we have 4u to power 3. So therefore, remember our function is dy dx equal to what? Dy du times du dx. Our dy du is 4u to power 3 times du dx is 2. So 4u to power 3 times 2 is 8u to power 3. So therefore, our dy dx is equal to 8. Remember, our u is 2x minus 5. So u, bring it back, is 2x minus 5 all to power what? 3. So this is our final answer.